Matrices. Maybe you've heard of them, maybe you haven't, but we'll be going over some of the basics. Ultimately, a matrix, which is the singular form of matrices, a matrix is a way of collecting data or numbers. It's a way of organizing them. And later on down the line, it's a tool that we use to do a lot of other types of math. So right now we're just going over some of the basics. We'll go over the elements of a matrix, what it is and such. We'll go over matrix addition and subtraction, and then we'll do some matrix multiplication. And we'll finish off, I'll give you a little bit of homework tonight to bring in tomorrow's class. Alright, now a matrix is usually written, it's titled with a single letter. So I'll call one matrix matrix A. We always put brackets around it like this. Now this letter has to be capital when we're titling it like this. So matrix A, I'm going to say, is a 2 by 3 matrix. So what that means, it's going to have 2 rows and 3 columns. Okay? So we'll have a number, number. There we go. So 2 by 3, 2 rows, 3 columns. If it were 3 by 2, we would have 1, 2, 3 rows and 2 columns. Remember, in the first place, a matrix is only a different way of organizing numbers, or sometimes data. Alright, so now let's name these. Any matrix will have, if we have a big A titling the matrix, we're going to name each element with a little a. So right here, our first one is going to be A11. That means first row, first column. Then we have A12, A13. And of course below we have A21, A22, and A23. These are the elements of our A matrix. Now remember, we could use any letter here. So if we had a capital B here, then we'd have lowercase b11, b12, b13, and so on. The most important thing to remember here is that a 2 by 3 means 2 rows and 3 columns. Now that you're a little more familiar with the definition of matrices, let's look at a few of the operations that we'll be doing. First two are addition and subtraction, and these are relatively straightforward, but there's one rule that you have to remember. That rule is that the dimensions have to be the same. Remember, the dimensions are the number of rows and the number of columns. So here we have matrix A is a 2 by 3 matrix, matrix B also a 2 by 3. So we can add them and subtract them from each other. This works with anything. So if it's a 2 by 4, you can only work with other 2 by 4s. If it's a 10 by 10, you can only work with other 10 by 10s, and so on. Now let's add matrix A plus matrix B. What we're going to do, element 1, 1, we're going to get from 1, 1 here and 1, 1 here. So the resulting 1, 1 is going to be A11 plus B11. So it's a 1 plus a 7. I'm going to write our final result down here. We get an 8. Then our second element, we have a 2 plus a 5. 2 plus 5 is 7. 3 plus 3 is 6. Second row, we have a 4 plus a 0. 5 plus 2. And 6 plus 4. So we have a 4, an 8, and a 10. A plus B gives us this guy. Now, what if we had A minus B? I'm not going to write it out all for you because it's pretty similar. The only difference is that instead of 1 plus 7, we'd have 1 minus 7. So once again, you're just looking at each element individually, and the result is going to come directly from its associated elements. That's addition and subtraction in matrices. So addition and subtraction are pretty straightforward when it comes to working with matrices. Let's look at multiplication now. There are actually two kinds of multiplication that we'll be working with when we're dealing with matrices. The first kind is called scalar multiplication. All scalar multiplication is taking one matrix and multiplying it by some number. So let's look at matrix A here. I'm going to take matrix A and multiply it by 2. In this case, 2 is our scalar. All we do is we take each element and multiply each element by that same scalar. So in other words, element 1, 1. You're going to get 2 times 1. Element 1, 2. 2 times 2. And so on. Just applying our scalar to each of the elements in our matrix. So the resulting matrix, 2 times matrix A, will give us this. 2, 4, 6, 8, 10, 12. The dimensions of our matrix don't change, only the elements.